linear pair perpendicular theorem. If two lines intersect to form a linear pair of congruent angles, that's the keyword, then the lines are perpendicular. So if we know that these two angles are congruent, they're on a linear pair, which means that they're supplementary and they add up to 180. So you have to know, yep, that they're both going to be 90 degrees. Okay, next one. So that's what that one says. Perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of the parallel lines, then it is perpendicular to the other. So this one, I need you to go ahead and mark this. It'll be helpful for you. You are given first that these are parallel lines. That is something that you know. And then you're told you have one 90-degree angle. So then the next thing that you say following is that you have another. Because they're parallel, these are corresponding angles, and so they're congruent. So if that one's 90, the other one's 90. So given parallel, you can say right angles. And the order does matter. 1, 2, 3 is marked for a reason. Next one. We're going to use this one a ton today. Lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel. So in this one, you are not given that they're parallel. On this one, what you're given is that, okay, these two lines are both perpendicular to this transversal, we'll call it T. So they both have right angles to T. That's the first thing that you have. What that means is that those two lines are kind of like locked in place. And so because of that, they end up being parallel. And you could use, like for this one, with the two that I marked, since they're 90, they add up to 180, so these are consecutive interior. So you can use the converse of that. Consecutive interior's converse says that they're parallel. But if they're 90, they're locked in place, so those have to be parallel. And the last thing here says that if we're measuring a distance, we always use the distance that is perpendicular to the line. So when you're doing distance from a point to a line, you use the one that is perpendicular. Always. Just like when we measure height of a person, we go straight up and down. We're doing the distance, we're going to go straight up and down. So sometimes it doesn't always look straight up and down. You have to look for the perpendicular line. So look for the right angle. That's the one you want. We're going to do some examples. So explain how you would show that M is parallel to N. Pay attention. You do not currently know that M is parallel to N. You are explaining how you know. Can you please turn to your partner for this first one? How could you say that M is parallel to N? Look at the theorems we just talked about. Okay, some ideas. Which one would it probably be? You can raise your hand. How do we know that M is parallel to N? What could we use to show that? Right now we have two right angles. Tori, what do you got? Yep. Lines perpendicular to a transversal theorem. Because M and N are both perpendicular to T, that means that they are then parallel. Because they're locked in place. They're both at 90. They're parallel. Okay? Second one, discuss. Which one would you use there? You have two. You need two theorems for the second one. Which I need you to talk to your partner about it. Which two would you use? Aiden, what is the first one we used? You can't use it because you don't know that they're parallel. Right now you don't know what the x's are. There's a theorem that tells us we could say what they are. What could you use, Aubrey? Right, the one at the top. So the first one that you'd use is the linear pair perpendicular theorem. And let's read what that says again. It says that if two lines intersect to form a linear pair of congruent angles, then the lines are they form a perpendicular. So because they're both x, they're both congruent. And so we know that these two have to be 90 because they have to add up to 180. And they have to be the same. So these are both 90. And then, so you got right angles here. So what's the second thing we use to actually say that they're parallel now? Sophia, what do I say?
Lines perpendicular to a transversal.
Lines perpendicular to a transversal theorem. Because right now I know that M and N are they both make a right angle with T, so they're both perpendicular to T. And since they're both perpendicular to the same line T, they are parallel. Again, one, you have that first thing, and then you can say the second thing. Probably starting out the same way, I got to figure out what x is. How could I figure out what x is? It's not necessarily one at the top, but think about like what do we use to say what x is? Aubrey, what could I use? You could use that if you knew that m was parallel to n. Because you don't know that m is parallel to n, you can't use alternate exterior angles. I like the idea. Tori, what could I use? Yep. So you can use a linear pair postulate, which says that these two are supplementary. So you know what this x is, and then you know what that one is. So linear pair postulate. Which is like an old one. If this one's 90, what does that one have to be? 90, because I add up to 180, right? So that one's 90, so this one has to be 90. And then the same one we've been using over and over and over since we know that they're both perpendicular to T. We can say that the lines are parallel, that is the lines perpendicular to a transversal theorem. Could you please look at the next example? So thinking about what we just talked about, again, you do not know that these are parallel, but looking at what you are given, the right angles, and where they're marked, which ones could you say are parallel? So there's only one pair of parallel lines. Okay. It's M is parallel to N. That's the correct one. But we need to explain why. How come we know that M is parallel to N? Ooh. Tori, what did you say? Okay. And so which M and N are both perpendicular to which line? Q. They're both perpendicular to Q. And so since they're both perpendicular to Q, we use that theorem, lines perpendicular to transversal. But I'll actually write it down. both perpendicular to Q, and so they must be parallel because they're like locked in place. They have to be perpendicular to the same line, so you can't say that M and like L are perpendicular because they're not perpendicular to the same line. If you want to use that to keep going, you could, but looking right off the bat, that's all we can say. Okay, let's switch to the back. These examples are, not bad. I'm going to help you out if you ever want to jump across this river so you know the shortest way to go. In case you didn't know already. This way, when I switch pages, it freaks out too. So if you're trying to jump across a stream from point A, which point should you jump to have the shortest distance? Which one, guys? So you should jump to point C because at point C is perpendicular. And remember, the shortest distance is always going to be the perpendicular line. Because it's perpendicular. It says to explain, so there we go. So likewise, which segment is called the distance between two parallel lines? Looking at example 3, which one do you guys think it is? Which one do you think we call the distance? AB, because it's marked perpendicular. So AB is the distance because it is marked perpendicular. Again, like when you're measuring someone's height, you want to measure straight up and down. Likewise, when we want to get the shortest distance, we want to exaggerate someone's height and go diagonally. So we want to make sure we take the one that's straight up and down. That would be AB, we know for sure because it's marked. So in the last one, find the distance from point A to line C. On these type of problems, you have 2 on your homework, I believe. You need to get out some paper. I don't care if it's like the back of your do now paper or something else, but you need to show your work on paper for these. And you'll see why in a second. So tomorrow we're going to talk more about how to know which line is perpendicular. But for today, go ahead and trust me. That is this one. And I can make that a little bit straighter. So from A to actually where C is marked, you're finding the distance from point A to line C. And so you want to choose the perpendicular line. On your homework, it'll already be marked for you. Look for the right angle. That's the line you want to find the distance of, or the segment you want to find the distance of. So we are going from the point 0, 2 to the point 3, 1. 0, 2 to 3, 1. This is like flashback to Unit 1. We did this. You have 2 options. You could use Pythagorean theorem with a right triangle and say, well, this side is 1, that side is 3, and so you can use a squared plus b squared equals c squared. Pythagorean theorem, plug in 1 and 3 for a and b, and then find c. Remember, the last step you do is take the square root. So you do 1 times 1 is 1, 3 times 3 is 9, add them up, take the square root. Or you can use distance formula, which I know you probably forgot, is the change in y. Nope, change in x, usually what we start with. Change in x squared plus the change in y squared, and then you take the square root of that. So we can just go, okay, so from 0 to 3, what's the change in x, guys? 3. And from 2 to 1, what's the change in y? 1. And so we just plug that in. So that would be 3 squared plus 1 squared, which is 9 plus 1, which would give us the square root of 10. I believe your homework wants you to round to the nearest tenth, so could someone find the square root of 10 for me? What do we got? 3.6. Round it to the tenth, 5 or above, go to a shove. 4 below, let it go. So we're going to say 3.6. And we could use that approximate sign, right? That the distance is approximately 3.6 units.